we're going to see how metals react with acids. Okay, so we've got sulfuric acid. Now remember, the definition of an acid is a substance which gives H plus ions when you dissolve in water. So sulfuric acid, H2SO4, when you dissolve pure H2SO4 isn't like an oily liquid, you dissolve it in water and it will give, it won't stay together like this here, a molecule of sulfuric acid with the hydrogen stuck to the sulfate group. The two hydrogens ions will separate with H plus, okay, which is drawn like that, and that leaves behind a sulfate ion, and they're floating around in solution with not touching each other, completely different from each other. All right, so we look at another strong acid, hydrochloric acid, HCl. That's actually a gas in the pure, but it will very soluble in water. Dissolve it in water, it will turn into an H plus ion and a Cl minus ion, which are drawn there in green. And those ions are separate from each other. And the last strong acid we need to know about is nitric acid here, which we've got here. So HNO3, that's going to dissociate into an H plus ion and an NO3 minus nitrate ion, which are drawn in as a blue there, floating around totally separate from each other. Okay, so let's see how how metals react with those acids. So you might have seen the general equation for this is metal plus an acid. That will give you a salt and hydrogen gas. And when I say metal, it's got to be a reactive metal, so that essentially means anything except the unreactive metals, which basically means copper, silver, and gold. Okay, so let's break that down a little bit and see what happens. So right here, before we look at the diagram, just look at this equation here. This is the reaction between zinc and sulfuric acid. Okay, so zinc and sulfuric acid gives you ZnSO4 and H2. Now, to write H2SO4 like that is, everyone know what it means, but it's a bit misleading to write it like that because we know really it is actually 2H plus and then SO4 2 minus ion. So in this diagram here, I've stuck with the symbols I used last time. So they're H pluses, and that is a sulfate ion. So there's 2 H pluses for each one sulfate. So you can see I've drawn in this beaker, I've drawn 6 H pluses and 3 sulfate ions. All right, and what we're going to add to that is we're going to add zinc, okay, which are these silver spheres which I've drawn here. Okay, that's the zinc atoms. Now, if we look at the equation here, this is a little bit more accurate. So I've split the sulfuric acid up into the H plus ions and the sulfate ions, which exist as, and you can see it turns into that. So what's happened here is you can see that the H plus ions, the red things, have turned into hydrogen gas here, and they've been replaced by the Zn2 plus ions. So if we wanted to make this equation simpler, we could look at the sulfate ions, and you can see they actually don't do anything. We call those spectator ions, so we can kind of cross those out. And we can see what's happening really is we've got zinc atoms, and they're reacting with H plus ions, turning into zinc ions and hydrogen molecules. We can break that down even further. If you look at the zinc, the zinc atoms are turning into Zn2 plus. Well, what's he got to do in order to do that? He's got to lose 2 electrons. And where do those electrons come from? Well, if we look a bit, if you think about it and see where they've come from the hydrogen ions here. those H plus ions are turning into H2 gas. So each hydrogen ion has gained an electron. And they've come from the zinc. So really in this reaction, what's happened is the zinc has passed electrons on to the hydrogen ions and made hydrogen gas. The sulfate actually hasn't done anything. And that's why the equation showing, the rub all this marks out. This equation here can be a little bit misleading because it looks like the sulfate has been, grabbed hold of by the zinc, and it actually hasn't really at all. Let's look at another example there before we finish. And here I'm going to do the reaction between magnesium and nitric acid. So magnesium is going to react with HNO3 to form magnesium nitrate. And that's the formula of magnesium nitrate in aqueous solution and hydrogen gas. In order to balance that, I need to put a 2 there. Right, so we can see in the diagram here, this is quite misleading because the HNO3 doesn't exist as that. It exists as, the HNO3 exists as a positive hydrogen ion and a negative nitrate ion, which is in blue. There we go. And they're completely separate from each other. And if we look, we can see that as you go from here to here, the nitrate ions don't change at all. They stay the same. They're spectator ions. So let's break down how would we write this as an ionic equation. We'd write down magnesium Mg solid. The nitric acid is broken down into ions. It's 2H plus and 2 nitrate ions. Now, magnesium nitrate, we can see here in this beaker, it's not stuck together. It's a separate, we've got those golden spheres with the 2 plus. They're the magnesium ions. So you've got Mg2 plus aqueous. The nitrate ions are just doing their own thing still. They're separate from the magnesium. And the hydrogen has turned into H2. These are the H2 molecules here. So if we look at, if we put the symbols in here, so we've got a magnesium has turned into magnesium 2 plus. The hydrogens, well, we've got 2 of those, and they've turned into a hydrogen molecule. But these, the nitrates, they haven't done anything. They've just stayed the same. They're spectator ions. So we can see the magnesium has gone there. Mg to Mg2 plus, it has lost 2 electrons. And we can see each of those hydrogen ions, it's gone from H plus to no charge at all. So each one of those has gained 1 electron. So what's happened here is the magnesium atoms have transferred electrons to the hydrogen ions. Very similar to the last one.